Okay, so if you're in my Algebra 2 class, you learned probably absolutely nothing. I'm kidding. You learned about logarithms. And it's one of the more kind of esoteric things, and yet there's so much history behind them, and I kind of want to talk about, just really quickly, some of the cool things about logarithms. So logarithms are, the common logarithm is base 10. And that actually shows up a lot in how we interpret nature. It's kind of like the decimal system. So, Richter scale. Richter scale, that's how powerful earthquakes are. So, the difference between a 1.0 and a 2.0 on the Richter scale is a factor of 10. So, a 2.0 is the same thing as if 10 1.0s hit at the same time. Now, think about that as we go from like a 6.0 to a 7.0 to an 8.0. So from 6.0 to 7.0, that's like 10. So 7.0 is 10 times bigger than a 6.0. And you wonder why people sit there and, it's like, well, if 6.0 is kind of a big deal and a 7.0 is, a bigger deal, and why do people freak out about an 8.0? It's only one number bigger. Well, the fact is that an 8.0 is 100 times more powerful than a 6.0. A 9.0 would be 1,000 times more powerful than a 6.0. So when you're dealing with logarithms, it's important to understand that little variations actually mean a really, really big difference, especially once those numbers get bigger. So that's how the Richter scale works. Another example is decibels. That's how loud something is. So the decibel scale is actually also logarithmic. And it's kind of in the name. You have deci, 10, it's for the logarithm, and bell, like the sound of a bell. But my favorite thing about logarithms, and I know I talked about this with one of my classes, and I may have talked about it with both, but here's a fun reminder, is logarithms are used to help the IRS catch people cheating on their taxes. So when you're doing number theory, one of the things you learn is how much numbers show up in daily things. And because all counting starts with 1, we know that 1 shows up about 10 times as much as the number 2. So for every 10 ones in a set of numbers, we'll find 1 2. For every 100 ones, we'll find approximately 2 10s and 1 3. And so on and so forth. So, if the IRS has your books and they scan it, and they go, okay, we're just looking for the ratio of numbers, 1 through 7. And they're like, okay, well, for every 1 1, we are having 2 2s, 1 3, 5 4s, 1 5, 7 6s, then we know that's a fake group of numbers. So, when you're cheating on your taxes, make sure you follow the logarithm.